that's a good idea.
All right, good afternoon, everyone. My name is Greg Probst. I am an alumni of Neumont University, and I currently work at Think Big, a Teradata company. And I have been there for almost a year and a half, if you include the enterprise that I went straight from into working there. Here we also have Brent Wernstrom.
How are y'all doing?
And then we have Claire, I don't remember your last name. Garza. And Neumont alum. Current Think Big employee.
Thank you.
Yes. And in the back we also have two more Think Big employees and Neumont alums. We have Jeff and Josh. They don't want to be seen. And what we're going to do today is we're just going to tell you a little bit about Think Big as a company, what we do and why it's great to work there, and then Brent's going to spend a little time talking about one of the specific technologies that we use that is particularly exciting in our field, and then at the end we'll hopefully have some time for some question and answer between us and these guys in the back as well about Think Big. So what is Think Big? Well, we are a big data company, and you can just read this. I'm not going to read everything on the slides, but we are a big data company. We're a consulting company, which means other companies hire us to come help them find solutions for all their data. So they have a whole bunch of data. Maybe they're not capturing it correctly. Maybe they're not storing it correctly. Maybe they have it and they just don't no clue what to do with it. We kind of provide a way for them to leverage that and make business value out of all of the data they're collecting. So it can be stuff like data analytics, predictive models, ingestion frameworks, just all sorts of different things, but on a large scale, large scale, machine learning. Some of the stuff we dabble in. So we kind of offer four major services. The first is big data strategy and roadmap. So we kind of go into a company and we'll say, this is kind of what we see big data being able to do for you, where you can kind of throughout the foreseeable future take your platform and make it better and more accessible, and provide more value to you. And that then, hopefully, if they like that, then they'll pay us to do an implementation of that work. So we go in and we have our engineers implement the things that we planned in our strategy, ingestion frameworks, and data processing. And then we also have a data science team that starts using that data to do some of the really interesting things like predictive models, recommendation engines, pretty much anything. Like for example, right now we have a project with Blizzard Entertainment, and they're going through the Hearthstone cards to try and equalize them out and find out which decks are imbalancing it, and so they can help balance the Hearthstone system. It's pretty cool. And then we also have training and managed services, which is a group of people in our company who go and teach other companies how to use what we've already created for them and how to expand and grow in big data services. So these are examples of a bunch of the technologies we use. There's so many that I didn't put them all on there, and I got tired of finding logos and dragging them on here. If you look at this and you're familiar with anything on there, you know that we're an open source shop. So we use a lot of open source technologies. And so if that interests you, it's a lot of fun working at Think Big. A lot of these technologies are very, very new. Sometimes the way that you get service for, where you can get support for them is actually just by communicating directly with the person who developed them. It's really fun to be kind of on that cutting edge of technology. And so yeah, if you haven't heard of any of these, it's because a lot of them are very new, but they're very fun and they're very cool. So here's an example of several of our clients that we've had. This is kind of an older slide. We've
You might recognize a few of these.
Yeah, you might recognize a few of these. This, we're not supposed to put the logo up, but it's a company that has a small piece of white fruit as their logo. And some ones that we have we've done more recently is also we're on Philips right now. So Philips Electronics, we're helping them develop a platform for their medical equipment, so that they all send their diagnostic data to a central area, and then we run analytics on it to predict when their machines are going to break down, so that they know where to send their repair people before it breaks down, so that they can reduce downtime on medical equipment and maybe potentially save lives. So that's kind of a fun thing. A couple others, an interlocking brick company, toy company that we can't say the name of, but any others you can think of before? I mean, you can say the name of them if you want.
And some of these that of course you'd recognize: Intel, eBay, Micron.
Oh, we're missing. There's another. You worked on another big computing company that I don't know how to describe them in a.
That has 4 colorful squares as part of their logo.
Yeah. Yeah. So we that's one of the cool things about working for Think Big, is you get to work with a whole bunch of different cool companies, and since we're consultants, we switch from projects semi-frequently, and so you don't get stuck with the same code base or the same issues or the same challenges forever, and so you can always know there's something new and exciting to learn and to challenge yourself on the horizon with somebody that people have actually heard of, which is cool. On to the next one. Okay, so where is Think Big located? Think Big North America has offices in all of these places. And Think Big International currently has 2 offices, one in London and one in Dublin. And there are lots of plans to expand. I know that they're trying really hard to get into China and other places internationally. So it's an exciting time to be a part of the company. The biggest office, definitely out of all of them, is the Salt Lake office. But there are quite a few people who work in these other offices as well. The typical way that Think Big works is if you're hired on as a new hire staff employee, you spend some time in Salt Lake City learning the technologies and learning to be a big data engineer or whatever position you go into. And then after spending some time here, you'll be able to have an opportunity to go to some of these other locations if that's what you want. It's all right. And so, what's it like to be there? Well, I can't say. It's got competitive salary and benefits. We're all pretty happy. So there's an emphasis on continued growth as an individual. So every Tuesday we have Talk Tuesdays, in which employees all take turns giving presentations on various technologies or frameworks or different things within the tech community that they might know about that they want to share with the rest of us. And it's a way for us to teach each other and learn. We have a mentorship program. So every employee has a mentor who is above them in like hierarchy in the company, but it's not their direct supervisor. So if they ever have issues that they don't feel comfortable maybe taking up with their direct supervisor, or they have questions that they don't want to like look dumb in front of their direct supervisor, they can go to their mentor and get advice in their career or help in certain technologies or ideas on where to go. And so it's really helpful. And we just instituted a badge program, which, I don't know, it's like an achievement system for our company. And so when you learn a certain new technology and you provide that you can do it, you get a digital badge. It's like a certification, basically, that's endorsed by our company. And it's on a third-party service, so even if you were ever to leave Think Big, I don't know why, but if you were to leave Think Big, you could show employees that and you say, hey, look, Think Big said, I know this, I know this, I know this. So it can be a good way of showing off your credentials in the future as well.
How many badges have you unlocked, Greg?
They haven't gotten to me yet, because you just started the system, but how many badges do you have?
I don't know, 12? Something like that.
You got a ton. You got a ton. So yeah, they're slowly getting to people and unlocking their badges. It's great. And then it's a work hard, play hard environment. So In Salt Lake City, we have a game room with ping pong, pool table, darts, video games, all set up in it that we're allowed to use to go and blow off steam during the day if we're feeling stressed or if we just need a little break. A bunch of us play games during lunchtime. And we also have Fun Fridays every week where we do activities such as, let's see, today they're going to see Captain America. We've gone snowmobiling in the past. We've
Next week is massages.
In-office massages. All sorts of great things.
Snowbird hikes.
Paintball, yeah. Bowling. We have a lot of fun. And there's lots of food at Think Big. We have a fully stocked break room with every sort of treat you could probably imagine from the healthy to the terribly unhealthy side of things. And the company provides us with lunch very frequently, usually at least once a week, oftentimes more. So it's a really fun place to work, but it's not just fun. There is a focus on people learning, on people growing, and being smart. We want smart people who don't just want to watch, as Steve Halliday would put it, code something to watch it fly across the screen. We want to tackle real problems and find solutions to them, and maybe we're using technologies where you just can't look on Stack Overflow and find the answer because they're so new. Yeah, go ahead. So yeah, that's the end of my part of the presentation. So now Brent is going to show you off a little bit about a technology that we use frequently and that's kind of growing in the big data space.
All right. Is that pulling up yet? Should be updating now. Yeah. Thanks. All right. We'll play from current slide. Yes, it's going, right?
Yep.
All right, here we go. So, yeah, so a lot of what we're doing is parallel computing. So you can think about some of these companies that you've probably heard more about, right? So Google, if somebody came to you and you didn't know that Google existed and said, hey, can you download the whole internet and then return searches on that within, what, 200 milliseconds, something crazy like that. I mean, just downloading the internet would be crazy to start with, right? I'd be like, no, I don't think I can do that as a project, really. And then there's Amazon. I actually know a little bit about the size of their catalog. It definitely doesn't fit on a single machine. And they're doing all sorts of cool things with the data that they have built around their different products that they're selling. They're getting thousands of new products listed every day there. So as you think about some of these problems, we can't just do this with a single computer anymore. We can't make the world a better place by just using a laptop or a desktop, right? So we need these parallel processing systems. First, so we can store the data, and second, so we can actually do something useful before the sun death of the universe, right? I mean, that's probably a good idea. So a lot of what we're doing is parallel computing. I'm specifically talking about a technology called Spark that's new to the scene, developed out of Berkeley back in, I think, 2010. Been gaining a lot of traction. Let's go to the next slide. And interestingly enough, I was just querying stuff on the internet today. Stack Overflow has a survey from last year that says the top paying technologies in the industry right now, Spark and Scala are listed 1 and 2. And Spark was written in Scala, so most of the stuff that you develop would be on Scala. Maybe money appeals to you guys, I don't know. Maybe not. But we'll get into some of this. So Spark is a general parallel processing framework. You can additionally write to it using Java and Python and R. SQL would be another one of those. It's also got some libraries that are specific to certain types of things you might do. If you're doing graph theory type problems, if you're doing machine learning type problems. But generally you'd be using core general purpose processing, maybe some SQL on top of that. Next slide. And then just to give a little background, what languages are people using? For those that are into math, you might notice these numbers don't add up to 100%. It turns out some people use more than one language, but Scala being the most common. And then back when this survey was done, 41% were on the engineering side of things, and then 22% were specifically data scientists, more doing the analysis type of thing. I don't know if they've come out with a more recent survey, but I would guess that as things progress, it'll start to shift more towards data scientists. It seems like new functionality is more for the data scientists, but there's still a lot of cool things you can do on the engineering side. Next. So why do I think this is cool? So before I joined Think Big, I was at Amazon doing a lot of coding in Hadoop, which was a Java general processing framework. And in 2013, there was a big 100 terabyte sorting competition that Hadoop won using 2,100 machines. It's sort of cool to use that many machines at once. Anyway, well, Spark came along the next year and said, I think we can do what you're doing better. And so they rewrote that framework and did it in a third of the time with a tenth of the computing capacity there, so 207 nodes. So first off, maybe to you it doesn't matter as much, but from a company, if you can cut back their expenses to like a tenth of what it was before, hey, that can earn you a promotion, right? And then second, if you can do it like a lot faster too, that's a pretty good deal. So with these type of statistics, it gained a lot of traction. A lot of people said, hey, we're willing, even if this is cutting edge and not all of the edges are polished, we're willing to give this a try because we think it can make a big difference. One of the big things that it does is it stores your data in memory on all these nodes. For this specific competition, I think it used it on the file system, but you can get even better performance if you can do it on your main memory machine. So depending on time, I might show you Spark in action. You can download this right now onto your machine and start running at the one node, however many CPUs you've got on your machine level, and start doing some stuff. The code actually doesn't look all that different when you move to a cluster and you want to take advantage of some AWS system or something like that. But we'll see how it goes. All right. So what's your basic unit here? So they've abstracted, and when I was in college, I had a professor that told me, abstraction is your friend. He told us to yell this in the room. I don't know if your professors are doing that kind of stuff. But their basic abstraction is what they call an RDD, Resilient Distributed Data Set. I don't know if that means a lot to you guys. But what's going on behind the scenes is, as a simplification, it makes it so that you can't update the data set itself. If you want to make a change, it writes a new copy of it somewhere else. So it's immutable, and a lot of the stuff that you do in Scala tells you try and make it immutable. Then it's a lot easier when everything's read-only to make it parallel. Distributed, of course, or we don't care about Spark. It's got to be on several nodes at once. And then the other thing, the resilient part is, hey, sometimes we're working on commodity computers. They go down. They're not always perfectly reliable. So if you're going along through your processing, you get to some point, you lost the node, you lost all this data. Well, it knew how it got computed, so it can go back and it can recompute that to that point in time, and you're back up and running, and you didn't lose anything other than the time spent getting to that point. So, and I'll show you what this looks like. It also creates this lineage graph, meaning as you're computing all these things in Spark, you tell it, I want to make this transformation. I've got this data coming in. I want to cut it into columns. I want to turn this string into an actual data object. And so all the time you're telling it, I want to do this, followed by that, followed by that. it creates this lineage graph and remembers, here's all the things I've done and I want to do to it, and then it performs an operation. So by having that, this is all the things that we've done, it can be resilient. And then more recently, and this thing is changing all the time, so you could have a new version out in the next month that could totally change all these APIs. There's a lot of developers on this because it's such a hot product. But they've introduced data sets and data frames. And so that is, RDDs are general purpose. You can store anything under the sun in there. But a lot of times your data is a table. You've got columns, you've got rows. And so they've found, as long as we know this, and we can have that schema in there, we can optimize some of this stuff and make it even snappier than it was before. So that's the new stuff. I won't get into too many details on that. But next slide. But here's what this whole lineage graph thing looks like. And you can have it split off. You can have it come back together. You can have it do a whole lot of things. And the part that might be a little strange to some people that might be used to like a bash shell, you type something, it immediately does it. It comes back. You go on to your next thing is, it does lazy computing. So you tell it all the things you want to do, and it says, cool, I'll remember that once I get to it. So it stores somewhere in the computer system. These are the things I'll get to doing, right? So it's sort of like us and our moms telling us what to do, right? We'll get to sweeping the kitchen floor sometime. But until that really matters, we're just going to remember that we need to do that. At best, right? For us, it's at best. But here it always remembers what it's supposed to do. So once you get to a point where it's like, all right, I need to materialize results now it goes through and processes things. So that means it can do things like, hey, I just want to look at some samples. It says, well, I won't read the 20 petabytes of data right now. I'll just pull off a sample, process that sample, and show you what it looks like now, so we can get some processing done and debug our script. Next. All right. So you guys can all read that? I can skip over this, right? No, probably not. All right. Who's done any Scala programming before? All right. Cool. The think biggers. All right. So I'll go over this. If you have any background in any programming language, which I hope you guys have, right, then you should be able to understand it once I get through this. But just some background. I did a lot of Hadoop programming before. With Hadoop, it's write 6 classes that you need to set up all this configuration so that they know this class is used for this, and then use that method when we want to do these operations. And so it's 100 lines of Java code before you're doing the most basic type of operations. Here we've compressed 100 lines of Java code down into, I don't know, how many lines is that? 5 lines of Scala code. Next slide. So we'll get into what some of this stuff is doing. So if you're doing this on the Spark shell, and it's not that much harder if you're not, but the Spark shell gives you this object called the Spark context for free. And the Spark context gives you a view into the world. So if you're storing data somewhere, like on the cloud, it can just pull that data down. And you don't have to do a whole lot about it. Just make sure it jars on your class path. So for this, we're reading text files. It can be things that are a bit more complicated than that. But for now, it's, hey, Spark context, I've got some data that you want to read as text files, and it's stored here. So here's a local path, but you just prepend some schema, or some scheme, I'm sorry. They'll say, hey, look on the cloud. Hey, look over here. And it's doing that for you. So this is a single file, but you can also give it a directory, and it'll read that directory for you. Next. So the next line, well, before I get to that, I need to give you a little Scala background. So Scala has a ton of these operators that are different things like this arrow. So we've got equals, greater than sign means, hey, I have an anonymous function, and by the way, this anonymous function is one line, and when it's one line, it just means return that one line. So if you have some long function in Scala, whatever the last line is, that's what gets returned by default. You don't need to explicitly say, return this. So when it's a single line, then it knows, return this. So this single line says, hey, create a function that looks something like this, and it'll infer all the types for you. So you don't need to tell it, return an array. It just knows the return type of this line is what is the type. We don't need to give it a name. It'll take as input a single object. In this case, it's a line. It can infer what that type is based on the context of your code. And then we're doing a split on regular expressions. Maybe you know regular expressions, maybe not, but this says if you have space characters, cut it up there, right? So you have one space, cut. You have 30 spaces. Combine all that into a single cut, and we'll do some stuff with that. So next slide. So for example, if you have the string, welcome to Middle Earth, I don't know why you'd be parsing anything like that. But then it'd cut it up into welcome as a word, to as a word, Middle Earth each as words. And so the way that we would do that is we say, hey Spark, we know you have some functionality that can convert these different records into different types. So generally, we're talking about map and reduce functionality. I don't know that you've gotten there, but if you have, the first step is the map operation, and so it's take in a record, do something, spit out a record. In this case, we have flat map, and so it's take in a record, spit out some type of collection. We don't know how many elements are going to be in there, but turn that collection into records. So it could be one record, could be 0 records, it could be 3,000 records. We don't care, but we know it's got some variable amount of records in here. So we're saying perform this flat map operation, and when you do, we're passing in a function to do all the computing. So behind the scenes, there's all this cool complex stuff that Spark does, which it says, hey, I've got some functionality. I'm going to serialize that code. I'm going to write that code to all these different nodes. We have 300 nodes working in the cloud. It'll send that code to each of these nodes and tell it, hey, start processing that data. I'll give you some data. Each of you can start processing your own little piece of the world and start doing that at once, right? So this is some very cool stuff that looks, at least to me at least, dead simple, right? It doesn't take a whole lot of code to start doing some very cool and complex things. Go ahead, next slide. All right, so on to the next. Scala loves the underscore. I don't know why, but it uses it everywhere as the wildcard. So in this case, before we were telling it explicitly, I'm going to get a single parameter, call that guy line, and then I'm going to start processing with that object. In this case, we're going to create an anonymous function, and we're going to take in 2 things, and I'm too lazy to even type names for those, so I'm just going to use underscores because I know that it's going to be a dead simple function. Most of the time for code readability, maybe it's a good idea to have names for these. We don't want to get too lazy with our lazy Spark evaluation. But in this case, just to show you that we can do it, underscore plus underscore means create an anonymous function that takes 2 things, add them together, return that. So now we're talking about 3 characters, and we're doing what in Java is, how many characters is that? I have no idea, but a lot more than 3, right? How many? 20? That's a good guess. 15. All right, next slide. Okay, so now we can use that. So we're doing 2 operations here. So again, back to the MapReduce paradigm. And we haven't fully explained that, but that's all right. So we're going to do a map operation. So what did we have before? We had strings, which were tokens, which represented a word. Which is why I chose to use words to represent that. So take a word object, which is a string, and return. And in this case, this is a tuple. So we just have a pair of things. Now, why does a tuple matter? Because we're going to be combining things that have the same keys. You'll see that in a minute. Anyway, so we have a string. Now we want it to be a string and a number. And then we can do very cool reduce by key. Reduce by key says, hey cluster, I want you to take every key that is the same and I want you to map it to the same machine. So all the machines in our huge cluster, make sure that they're all writing out to different places, and I want you to map each of these unique keys to a specific machine. So MapReduce, that was something cool Google was doing a long time ago, and hey, what do you know, we're still doing it. So every time that you see Earth, right from our Middle Earth example, I want you to write that to node 251, and then we can combine all of those Earths. I thought there was only one Earth. Nope, there's actually multiple. In our example, we're not getting too philosophical here. And then add up how many Earths there are. So this little passing to reduce underscore plus underscore is the same as this Java thing where it says store the result of the first thing into this temporary result variable and then iterate through every one of our Earths, add them. So this is our function here. Send the previous result and the current thing that you're looking at to this function. In this case, add them together. Set that equal to your temporary result and iterate through that whole thing. So we pass a very simple function. Behind the scenes, Spark says, I know what to do with these aggregating functions. We combine two things one at a time, and voila, we return at the end a sum. So with just a few characters, we're doing a sum across a computing network, and within hopefully minutes, possibly hours, we have our results. All right, next. Okay, but have we done anything yet in Spark? No. We've just told it, here's some cool things that I want you to eventually get to doing, but it's not done anything yet. Right? It's just storing that in a lineage graph before we actually do any computing. All right. So unless we do something with it, it's not going to materialize anything. Next slide. Okay, so things that you might do that might materialize results. When we're in the debugging mode, take is very handy, which says, hey, I just want to see what 1 record, 5 records, 10 records looks like. So I know, 1, hey, I've got results, and somehow we didn't lose our results so far. And 2, make sure that we're actually processing that date correctly, or, I don't know, determining if there's a drum solo in 30 seconds of, I don't know, music data, something cool like that, right? It could be anything. Other things you might do, count. That should be fairly obvious, right? How many records have we got? And then lastly, you might want to write this out somewhere. So you've done a lot of processing. You write it out somewhere to be used for future processes. Maybe it's used by, I don't know, a dashboard or something. There's a million things you could do, but we want to write those results out somewhere. So let's do that. So save as a text file, save as some Hadoop file, save to the cloud, save to disk, wherever you want to materialize it. Now once we get one of these operations, now the laziness wears off. It says, what was my task list? Let's do it. And it goes about performing those. Next. Okay, and then as a bonus, looks like we will have time to do this. I'll just write all this up in the shell so you can see it live. Lastly, hey, if we're doing word count, what are the most common words? So then it makes it a little more interesting. So if we wanted to do that, we would do another map operation. And now we know what our records look like. So instead of saying, give me a tuple object, let's map that to a k and a v variable, a k representing the key and a value represented by v. And now we can do what with this? Any ideas? Reverse it, right? So the key becomes the value and the value becomes the key. Why? Because we want to sort by frequency. So now we can call the very simple sort by key. Guesses on faults? Yeah, ascending or descending. So false on ascending, so we can get the most common at the top. Then we take 5 and we get the 5 most common words. All right, let's see. Yeah, so let's take this Spark stuff for a spin. Alrighty, I had this shell. I should have moved to. Alright, so now you know the structure of my world. Let's see. Alright, so I can type it up that easily and it'll start up a shell. There's other parameters you can get, like try using a cluster called yarn. I want 3,000 worker nodes. For all those worker nodes, I want them to use 60 gigs of memory and, I don't know, 16 processors, something like that. Maybe not typical for a project, right, Josh? I saw you saying wow. But it could be that easy, right? Yes, errors. That's what demos are for, right? What did we get here? How'd I break it? Uncaught exception. Beautiful. Really? Okay. You failed me. All right, let's try this again. Let's see if it starts. If not, we have plenty of other Spark shells that will probably work. Ba-ba-ba. Lovely. You depend on these things to work, and then sometimes they don't. Yeah, let's make that bigger. Bigger, bigger, bigger. And it failed again. Good job, guys. Alright. Older version of Spark. Here we go. Or, we'll see if maybe I screwed something up on my machine. That wouldn't be the first time. Alright, if this doesn't work, we'll have Claire animate it up on the whiteboard.
I don't like that.
Oh, that's not a good idea? Alright. Ooh, failure once again.
Launched it.
Maybe it's just the SQL context. Let's see how this guy works. SQL context, how are you today? Not found, that's not good. Alright. Okay, suddenly I don't have permissions to do things on my machine. That's awesome. Good job.
Launch it with sudo.
Yeah, we could try that. Let's pretend that this works.
We're not desperate now.
That's right. Give me all power. Do not deny me. I'm the Grand Wizard on my machine.
We'll see if it agrees.
And if not, we'll go straight to questions. You guys, we'll see. No. Yes, failed. All right, so let's pretend that worked. So how cool is Spark, guys, right?
Exceptional.
Yeah. All right, so let's move to questions then. Yes.
Do you know if Spark supports stuff like Xeon 5 or CUDA support?
Say again, what?
If Spark supports CUDA or Xeon 5 support?
I haven't seen support for CUDA under there. Yeah. What's that?
So you guys use Scala. Do you use any closure in your shop or no?
I don't think we have. I mean, every project is very unique, and so a lot of times it depends more on what are the customer requirements necessarily than how we'd like to design it from scratch.
I just put those up so they can see it.
Oh, yes, good job. Oh, yeah. So the more important part, I got a little flustered with things breaking all around me. We are hiring both data engineers, which would be what we are, which is creating the parallel systems, and then also Hadoop admins, which would be administrating those systems. So either you can apply directly online, or you can send an email to Christine, who I haven't met yet.
I have.
Since we're a little spread out. Have you?
Yeah.
Nice.
She's a firecracker.
Is she?
Yeah.
Awesome. Yeah, so, or you can send your resume directly to Christine, who's overseeing the hiring of those positions. All right, sorry, back to questions. Yeah?
Is the first 2 months
First 2 months. Okay, so we have for all new hires scheduled a what we call a boot camp. And so it doesn't involve sweat and blood and mud and, you know, those type of things.
Unless we go four-wheeling.
Yeah, unless it's four-wheeling on the fun Friday.
We did at my boot camp, so.
Did you? Okay.
Involved, yeah.
All right, so, let me take that back. It usually does involve mud. But so we have a boot camp that's about 2 weeks long. And we have some of our professional training staff that'll go through some of our basic technologies that we're using, Hadoop and Spark and Hive and some of the other ones that are listed on that slide. They'll give you a background about the company and how to sell us. And then after those 2 weeks, you're available for whatever. So it's not like other companies where you're building the products for your company. It depends on what consulting projects there are at that time. So there are lulls. Sometimes there are periods of time where you're not directly working on a project and you're free to learn whatever the heck you want. Certify, that's right. Yeah, get certified in technologies. Build your own resume, right? Things that aren't bad for yourself as well. But once you're on a project,
it's full on
development.
Yep. So, for example, when I first got on, I was immediately put on a project for Ancestry.com. But with Claire, I think it was a little different. She had to wait a little while. So, what did you do?
I actually had 3 weeks of Teradata training. Teradata is a company that just acquired ThinkTech.
Do either of you wanna?
So we're just we're just like a subset of that. So I did 3 weeks of Teradata training. Do you want me to clip it on myself? And then I did the boot camp. And then we did something called Project Certify. So I got HDP Hadoop Hortonworks Java Developer Certification. So that's mostly what you'll go into. You'll go into certifications right after training before you get on your project.
Jeff, did you want to talk about any of your experiences?
Sure. So mine was a little different than most people. When I started 2 weeks after, I immediately got put on a project. They flew me out to California to work on that project for a week, and I didn't have boot camp until 3 months after I started.
So not always immediately following your hire.
But pretty soon.
Yeah.
Pretty soon.
Yeah.
And when he got on it, they were less frequent boot camps. Now we have them more frequently.
Yeah. When I started, they only did boot camp every 3 months, so I had been hired 2 weeks after the previous boot camp. We now do them every 1 to 2 months, so my experience will be a lot less common.
Yeah, and as Jeff mentioned, there is a possibility that you can travel out to see these clients wherever they may be in the U.S. If it's exciting to you to fly to Boston or Texas or California or go into various company headquarters, that can be pretty fun too.
Yeah, Brent spent a lot of time in a company in Redmond, Washington.
Yeah, I was in Seattle, I don't know, I think 20 times last year.
Yeah. But I mean, but if traveling's if you're not eager to travel, they are usually pretty understanding of that as well. So it goes both ways. If you want
Salt
to
Lake developers don't necessarily have to travel as much.
There's those opportunities, but if you don't want to, it's a...
So most of you said you get put on projects. Do you have any say in what projects you end up working on, or are you automatically put on ones no matter what?
Go ahead.
I just think it's really cool because I've been on 2 projects so far in the year I've been in the company. I started on Ancestry, which is a really data science heavy, and like what they wanted us to deliver was really vague and fuzzy, and so we were kind of just a whole bunch of like data engineers and data scientists sitting in a room trying to solve these graph problems, because that's what Ancestry is a bunch of graphs. And it was a whole lot of fun, but I didn't but at the end of it, I didn't feel like necessarily I knew how to work in a structured project, because it wasn't very structured. So I specifically asked, at the end of each project, your mentor goes over with you, what you thought about the project and what you'd like to do in the future. And I said, I'd really like to work maybe on one of these bigger projects that are more structured, so I can gain that experience. And a week later, I was put on one of the biggest projects we have right now. And so, and it's been a good learning experience. So yeah, we do have say in kind of what we want to do.
And also it makes a big difference what your certifications are, what your experiences are. The more expert you are at something, the more likely you'll be put on a project doing that thing.
So I've been working here for 2 years. I just want to put on the fact that you do have some say, but most of the time you don't. They're just going to throw you on a project, and it's like your time to shine, sink or swim. We have a work hard, and it's extreme. So if you want to learn something, they're going to be like, okay, learn it. You still got to put in your hours, though. And I don't mean to scare anybody off, but I've been on 4 projects. I'm about to be placed on my 5th. And I've done everything from QA to Hadoop admin to a little bit of data science. I've done my own solo Redshift project for a client. They wanted to be able to pull in 50 tables from one server in Singapore and 50 tables in Oregon. So, and I've learned a lot. Most of the time I didn't get a say. They were just like, hey Josh, we need you to be on this. And they just hope you go, yeah, that's awesome. It's a great learning opportunity. And they're not going to be like, oh, you failed, you're fired. They're mostly going to be like, hey, you need to work on these skills. We're going to put you in somebody who knows these skills. You're going to work alongside them. You're going to learn them. And it's quick. It's fast. So if you like that kind of style of learning, you're going to love it.
I would just like to add, they're very good about not making you just sink and swim. They're very good about making sure you're learning what you want to be working on, and that you have someone that's higher than you so that you're not uncomfortable with whatever you're working on. That's a very big deal. We have like 3 questions now.
That's great.
So you say you do a lot of projects. Is new engineer, is it salary based, or are you paid depending on like when you get your project done or projects you work on?
It's salary based.
Okay.
Yeah. Since you don't necessarily have a say if you're on a project or not.
Right.
Then yeah,
So
it's salary based.
There's a bonus program that we all have. So you have your base salary, and depending on how quickly you finish your project, or how well you're doing on your project, or how many certifications you get, your bonus will increase that month. You get it every month. It's not like a yearly bonus. So that's really cool.
Let's go into the back next.
Yeah.
He's had a question.
So I was wondering what you guys had in terms of remote working opportunities. If you guys have any of that.
What was the question?
Yeah, so about half the time our office is empty, and the other half it's like super booming. I mean, we have people, so we have someone who just gave birth, and she's working from home. We have people who they want to go visit their parents, but they don't want to take time off, so they travel out. They take a day off to travel, and then they work from their parents' house in Michigan and that kind of stuff. So we're pretty understanding.
It's very like, if you can be in the office, great. If you can't, just work wherever you're from.
Yeah, it's mostly, are you going to stay at home and play, you know, new Dark Souls that just came out, or are you going to stay at home and get your project done? Yeah, so.
It'll show up in your bonus. It depends on what you want.
Yeah.
But yeah.
Yeah.
And there was a couple that you said you've been with ThinkVic for at least a couple of years. What makes you stay?
I love the projects. I'm learning stuff that most people don't even know about. I get to tinker on their systems. I get a lot of resources for learning, almost as much as I had at Neumont. I could pretty much take any certification, any Coursera class, and it's backed. Like, I just love the opportunities that I have there, and the people I get to meet. I met somebody from one of the world's biggest MMOs that I'm a huge fan of. So, just really cool opportunities.
So one of the things that keeps me here, I've been with the company, it's getting close to 2 years, but not full 2 years. I like being able to work on the different projects, having different opportunities to work with different code bases and different technologies. I find it kind of boring just to work on one thing over and over and over again, so being able to switch what I'm working on is really appealing.
Year and a half.
Okay, yeah. Those are the more than coming up to more than 2 years or almost 2 years. But to get with it for me, I mean, me and Brent have been about a year and a half. I just I don't know, going to working on a JavaScript shop and doing full stack web development just sounds like it would get arduous and boring for me. And real problems, real working your brain to solve them. That's what keeps going into work daily. That's appealing to me. And so if it's the same, if it's just making stuff fly across the screen, I'm not. That doesn't appeal. So.
Yeah. And I'm all about these technologies. Yeah. Go ahead.
So you guys have mentioned moving into new projects and code bases. How long do you usually spend familiarizing with a new code base for a project? So like getting that
Onboarding on a project. It's usually 2 weeks. I've been thrown on a project, and I was expected to know the whole project in a day. You don't really know what legacy is until you have to like go through 2 to 3 million lines of code, and you're like, I have no idea what this guy did. There's no notes or anything. Most people are understanding. The PM you're on will usually be like, hey, take 2 to 3 days, read through the project. This is the task you're expected to do, so just become familiar with that and then branch from there. And you're usually on a project 6 months to a year, usually. Depends on what the SOW and what the client wants. And then after that, if you want to be rolled off, you're rolled off. If you love the project so much that you're tied to the code, you pretty much get to stay.
And sometimes it's from scratch. Yeah.
For these projects, how big are the groups that you guys will have to, or is it a lot of solo work?
It's variable.
Yeah, we've had projects as many, so 2 to 15 people. Usually they try to keep it to 7. 7's been the magic number so far. You can expect most groups to be between 4 and 7, but we've had a project with genealogy data here, based in the valley, and we had 2 people on it for a while, and then it bumped up to 3 to 4. So just depends on what the client wants and how much they're willing to pay.
Yeah, if they pay us enough money, we'll throw every developer at it. So.
Yeah, I was by myself for like 2 weeks on a project, but that was a unique thing.
What's your project management like? Are you guys using Scrum?
Loosely.
Scrum-based, agile, you know. Nobody gets Scrum 100% correct, but it's mostly stand-ups every day, sprints that they tried it to be between 1 to 3 weeks.
I think the stand-up is the only thing that's consistent.
Yeah.
But a lot of that is because it depends on, oftentimes, too, the client's methodology as well, right? Because sometimes you have to integrate with their development teams and stuff and follow along with them.
Okay.
So.
That's a great point.
All right, and it looks like it's time to cut there.
But we'll be here to answer questions.
We'll be here to answer questions.
So you can just come right up and ask us.
Yeah.
We'll be outside.